Hello, this is Toby. Welcome back to the series where we make a programming language. So we're making the programming language called Smalling. This is the stage where we're putting the finishing touches on this language, small as it may be. And the way I usually try to find holes in the language is by writing various programs in it. And one way to get to do that is by solving coding challenges. So I chose this Roman numerals encoder challenge from codewars.com. Last time I started on it and ran into some issues with the language, ran into an ambiguous grammar issue, and I had to fix that. And at this point, we have this program that is going through with an if statement to determine what Roman numeral to produce given a single digit number. And at this point, I'm thinking, gosh, this code is going to be very tedious. Is there a better way to do it? So I decided to take a look at the problem from a higher level. So let's look at the Roman numerals chart from 1 to 100. Interestingly, 0 is not defined. They don't have a way of saying 0 in Roman numerals. Great. So the way I see it, the Roman numerals is based on 2 digits, right? It's based on 1, 5. There's a version of 1 and 5 in the tens. And there's I believe there's also a version of 5 for the 100. Yes, that's D. So D means 500. M means 1000. Let's say there's a ones place, there's a tens place, there's a hundreds place, and there's a thousands. Although I'm not sure if there's a letter symbol for 5,000 defined or not. So for each one of these places, there's a symbol defined for 1 and 5, right? This should be C and D. And then M and maybe there's a 5,000. I'm not sure. For each one of these cases, you can break down the digits. For the ones place, tens place, hundreds, thousands. So for ones is I. Why did I miss 8? I don't know. So I'm gonna stick 8 in here. This is terrible. Maybe I should use a spreadsheet to do this. And for tens, I believe we have this exact same thing. As in, we gonna take the 5 for tens, which is L, and put the 1 to the left of the L for the 4. And then 5 is L. L stands for 50, as we see here. And then we have LX, LXX, LXXX, LXXXX. Let me verify these actually. So 80 is LXXX. Yes. And 90 is, oh, I got 9 wrong. This is actually x minus 1, and this is going to be c minus x. If there isn't a 5,000 symbol, let me Google it. There is. It's V. Is there more? Yes. It's this V with a bar on the top. Holy crap. And then for 10,000, it's X with a bar on the top. So 5,000 is going to be a V with a bar minus 1,000. So each of these columns follow the exact same rule as far as I can see in terms of the pattern in which it first uses the ones, and then when it gets up to the 4, it does the 5 minus the 1. And then when it's 5, it uses the 5 symbol, and then it's 5 plus. Until it's the 9, then it uses the 1 from the next column minus 1 in this column. So all of these follow the exact same pattern. If you have multiple digit, the way to handle that is to, like, if you have like 56, then you just split these two guys up. And then you can say render each digit individually. You render the 6 in terms of the in terms of the ones column, and you render the 5 in terms of the tens column, and then you jam them together. So 6 would be a V and an I, and then a 5 in terms of the tens column would be a, is it an L? 50 is an L? Yes, 50 is an L. So then you just concatenate those two strings together, and then you get LVI. Is that right? Yes, you get LVI. 28. We're gonna split them up, and then 8, we're gonna do it in terms of ones, VIII, and then for 2, we're gonna do that in terms of tens, so we're gonna get XX. So the result is XXVIII for 28. Yes, and that's right. So I think that's how we're gonna do it. We're gonna use a recursive algorithm because we don't have loops in this language. If you're using a Lisp or Lisp-like language, then recursion is all you got. You better get good at that recursion, man. Basically, the algorithm is going to be take the number. We're going to find the digit in the ones place by doing a modulo. Do we have a modulo? We're going to add it. We'll probably encounter a lot of things that we don't have. So the number mod 10, and we'll get the ones place digit. Actually, we don't necessarily know what place we are, and I think that we need to be passed in as a parameter. I'll just say this is the digit. You might tend to get the digit in the current place, and the place might need to be passed in as a parameter to your function. So you have your digit. We need another function that will take this digit and the place number and give us, I'm gonna call it render Roman, maybe? I don't know. Or it's like a helper function that'll take a digit, a place, and then give you the Roman notation. And then we're gonna take the remaining number. Remaining is probably not a good name, but basically the result of dividing by 10, which, like, if we have a number like this, 128, we're dividing it up, we're peeling one digit off. This is the digit, and we're calling it this the remaining. Remaining might be okay. So the remaining we recursively call ourselves. So this is just render a digit, render Roman digit, and you give it a place. So depending on if the place is 1, then it'll render like that. But if the place was 2, maybe, then it'll render LXXX for the digit 8. So that's the plan. Let's try to make this happen. I'm gonna just start over. I'm gonna first make this function the easy one. I'm gonna call it a convert digit to Roman, and that is a function that takes a digit, which is a number between 0 and 9, I believe, and a place. Let's put a line of comment. Digit is a number between 0 to 9, and place is a number representing what place. 1 means ones, 2 means tens, 3 means hundreds, and 4 means thousands. Let's do it like that. So we have our comments. Hopefully that helps. So given a digit, it depends on the place. So I actually want to make a separate helper function for 1 and 5. So 1, I think this will help. So based on the place, if the place is 1, then I want to return I. Else, so this 1 function will give me either a I, or in the ones case, or a X in the tens case, and hundreds I believe is C. Yeah, C, or a M. It will return one of those 4 things. Actually, I'm thinking instead of doing this, there's a faster way of doing this. I'm just gonna make an array no, not even an array. I'm just gonna make a string like this, and then use array indexing to access it. I'll make a function called at, which you pass in an index, it'll index into this string, okay? And then this, we just have to subtract 1 to the place to make it 0 indexed. That's it. I'll make another one for 5. For 5, it'll be V, L, 500 is a D, and then for 5,000 is V with a bar on top. Oh, that's not a symbol? Okay, use this guy. I'm gonna use this crazy looking symbol. It looks like a D with a smaller D inside of it. That looks awesome, actually. Wait, where's the 500? 500 is D. Okay, there's a normal D and then the D with the inner D. Okay, so that's how you get a 5. And now I believe I can say, so if digit is 0, then we're just returning an empty string. Else, if the digit is 1, we're gonna return a 1 for that particular place. Else, if the digit is 2, then we'll say concat together. We could actually use recursion here. Would that help me though? Would that help me write less code? So if I did it like this, I'll need an OR. If it's a 2 or 3, we're gonna just subtract 1 and then make it recurse like this. Else, if the digit is 4, then let's do I feel like this might be like a little bit indirect here. Maybe do it like have a repeat function. Maybe if it's 1, 2, or 3, let me do it like this so that we just have less nesting, because this nesting is kind of bothering me. So if it's 1, 2, or 3, and I could make up whatever function I want. I'm gonna implement them as long as they're not too difficult to implement. I'm just gonna implement these functions as we go. So say if the digit is 1, 2, or 3, we're gonna repeat digit number of times, and that kind of allows us to take care of 3 with one clause. Although that does make me think that perhaps we need some sort of a way to have if-else statements, or perhaps we simply indent it differently. Maybe we just indent it like this. Yeah, we could just indent it like this so that this huge if statement isn't quite so onerous. Okay. It's still kind of onerous. What about if the if statement could take any number of conditionals and the JavaScript runtime function can test to see if it's a conditional? I actually don't like that idea because unless we wrap the conditionals into another function, that's gonna sort of prematurely calculate all of the conditionals, and I do not want that. That'll make it impossible to do guards and stuff like that. I'm gonna go back to this very, very nested way of writing this code and just hope we can get through this alive. So if it's 4, then it should be 5 of this place concatenated with the 1 of this place. Else, if the digit is a 5, then we just want the 5 for this place. Else, if the digit is a 6, then we want to concat the 5 of this place. For 6, 7, and 8, we could do this same thing. We can concat the 5 in that place with the repeat of the digit minus 5 of the 1's place. We can do it like that. And then finally for the 9, we're gonna concat 1 for this place, and then we're gonna concat that with the 1 of the next place, which is place plus 1. And if it's none of these, if there's a way to throw an exception, I probably would, but lacking that, I'm gonna return an exclamation point. And now we need to close all these parentheses. But I have written code in Lisp before, and this reminds me of that. I'm gonna try to test this function here. So if I convert the digit to Roman for 5 for the first place, let's see if this works. No, it does not. Syntax error. Oh, I tried to use a minus sign. We don't have operators in this language. At least not yet. Okay, unexpected R brace token. I did open a left brace though. So I'm gonna do a test case simplification to try to solve this. Oh, there might be a problem in my parser, unless I'm missing something. I mean, this should parse. So let me put this code back, but I want to simplify this. So I'm gonna make a new file, call it Roman2 for debugging purposes. I'm gonna delete this if statement. I'm gonna simplify this code by a lot, so I narrow down the source of this problem here. So it is able to parse example 4, which looks like this, but it's not able to parse Roman2. Okay, so what's the difference here? Is it that the name of the variable? No. What is the difference? Okay, I'm gonna put example 4 small into Roman2 small. I call this the bug sandwich. So this one works. I'm gonna reduce it down. This still works. This still works. Oh, so without a statement inside, it breaks. Oh, this works, but having just a 1 doesn't work. Oh, but having an if statement works, right? Yes. Okay, so one thing that doesn't work is an expression. I think I should unify statements versus expressions. I probably just shouldn't have the concept of statements in the first place. All statements or expressions would allow you to do something like this, because this should be allowed, just returning a 1. But the thing that did not work is this if statement here. Oh, it's probably this wanting to return this string that didn't work. Maybe, like, what if I did this? So I'm gonna try start simple here and put this in here. It should like it if it's just a function call expression. Oh, now there's an error in, oh, because I have an extra paren. I closed off this paren. So it's a parenthesis matching problem. I think we're in the middle of a very big function call expression that didn't close off properly. So I think what I might do is to try to do it section by section. So this works. So it's in here somewhere. This works. So it's in here somewhere. This works. So it's in here somewhere. And that works. So it's in here somewhere. That broke. So I think it's probably here. I have too few parentheses is my guess. Oh, now that worked. So the problem is with the mismatching of parentheses in this very, very large if statement. Let's try to run it. At the moment, the programming language is not giving you very good error messages when you make a mistake, and that is something that I plan to cover in the future. How to how to give user better feedback, better error messages when they make mistakes. But at the moment, it's pretty bad. All right, I think we're in business. It's saying or is not defined, so we'll just define a function called or, and we'll probably be fine. Let's define a function in the runtime. At, so at is for indexing, and called at. Whoa, okay, 4 for the ones place. That's correct. So what about for the tens place? It's XL. Yeah, that looks good to me. Test a few more, like 1 through 9. On the tens place. Repeat. We're gonna need a repeat function. So let's make a result, and we'll just say start it as an empty string, and then we'll just loop result plus equals string, and then return the result. There's your repeat function. In JavaScript, we actually need commas. So that's looking good to me. And if we change the place back to ones. Awesome. Okay, so we can convert a number to Roman for 1 digit. Now let's do it for any number of digits. So I'll call this convert number to Roman. How about that? And convert number to Roman takes a number. We may need a helper function because we need a starting place. So I'll make a helper function here, which will take a number and a place. We'll start it at the ones place, and then it'll gradually increase. Okay, so we'll take the number and mod it, modulus the number by 10 to get the current digit. And then we're going to convert that digit using this function we already have. I'll say the left part. Oh, this would be the right part actually. Right part would be convert that digit to Roman at this current place, and then we'll take the left part would be divide the number by 10. We want integer division, so we need to floor it, I think. Unless it's an integer, but in JavaScript it is an integer, and we are using JavaScript underneath, so it could have a decimal there. So we're gonna floor it, and then the left part we're gonna recursively call ourselves to convert the left part based on place plus 1. We're gonna add 1 to the place, convert the left part. I feel weird calling this left and then calling this left part. I'm gonna call this remaining, even though it's not a good name for it. I'm still gonna do it. And then finally we're gonna concatenate the left part together with the right part, and that is our answer. See if that works. I'm gonna comment out this code. I'm gonna print, convert this number to a Roman. What's 45? Modulus. We need a modulus function in the runtime. We also need a floor function. Maximum call stack size exceeded. We're trying to do recursion without a terminal case. Why do I do that? I think the terminal case would be if the number is 0. So if number is 0, then we're just gonna return an empty string. Else, we will do all of this stuff. Okay, see if this works. Oh, yeah, 45. Yeah, that's a 5, and that is a 40. I'm gonna look it up And yeah, it's XLV. So we have 45. I'm tempted to want to print this table out at this point. And in order to do that, we need some more runtime functions. Maybe in the style of Python, we might have a range function that starts from 1, goes to 100, and then we're gonna each over that range. And then for each number, we'll convert it to Roman, and then print out the number, and then equal sign, and then the Roman numeral value. And in order for that to work, we're gonna need a couple more functions. So we need the each function. We need the range function as well. Range that takes in start and an n number, and we'll say we'll make an array of numbers starting at the start. And I think in Python, let me just test it out in Python. 1 to 100, converted to a list. It includes the 1, but not the 100. Okay, let's follow suit. .I equals start, and then do it until I less than end. And then we'll push the I into this result and return the result. So that's our range function. Let's have an each function. Takes an array and an function, and we'll just use JavaScript for each, like so. Oh, that is looking good. Let's format the strings. Maybe I'll use concat a couple of times. This is looking pretty good to me. I'm gonna do some inspections of the value to verify if it's right. We didn't include 100. Okay, let's include 100 by bumping this to 101. Okay, 100 is C indeed. While we're at it, why don't we go up to 10,000? Oof, ouch. We have undefined. We have a 5,000 defined, but we don't have a 10,000 defined. Let's define 10,000 then for the 1, and then we can define the... Yeah, I don't think that symbol is recognized by the browser. I'll stop there. Whoa, that looks weird and beautiful. Okay, so I'm happy. I'm happy with the result of this coding challenge. I would say this is a programming language now. If you can solve something non-trivial, like converting a number into a Roman numeral, then I would say this is good enough to be a legit programming language. Is it a good programming language? Well, no. However, that's why you are doing this. You made your own programming language so that you can make changes to it yourself. So you have the power to improve this programming language. This is gonna conclude this series. However, the long journey is not done. I plan to put out more content on this channel, as well as in the How to Make a Programming Language series. There's a lot of issues that if you want to make a robust programming language that you expect to be able to use comfortably, that you need to solve. And I plan to cover those topics.